Binomial theorem. Binomial theorem for positive integer. So this is binomial theorem. A plus x whole to the power n. So two terms are there, that is binomial. So a plus x, then within bracket, and then power is n. Just as a plus b whole square. We know all about this. A plus b whole square. It is a square plus twice ab plus b square. So when a plus x whole to the power 2 means a square plus twice ax plus x square, like that. So a plus x whole to the power n is a positive integer. N is a positive integer. It is given as nc0 a to the power n minus 0 b to the power 0, nc1 a to the power n minus 1 b to the power 1. So like this. It is so when a plus x n is 2, then it is a square, which a 2c0. We have known about this combination. So 2c0, then a to the power 2 minus 0 is 2, and b to the power x, it is x to the power 0, plus 2c1, then a to the power 1, b to x to the power 1, and 2c2 plus 2c2. So it is a to the power 2 minus 2 is 0, and x to the power 2. So 2c0, it is 1, then it is a square plus 2c1 is 2, ax plus x square. So this is for n equal to 2. For n equal to 3, it is 3c0. 3c0 is 1, then a to the power 3, b to the power 0, like that. And general term, we say it is general term r plus 1. So ncr. So in this case, when r is say 0, then it is t0 plus 1. So first term is 2c0 a to the power 2 minus 0 b to the power 2. So ncr is the binomial, are called binomial coefficient. Now for negative integer or fraction, we need mod of x less than 1, and first term should be 1. So 1 plus x whole to the power. So this is our formula. In this case, we don't write nc0, nc2, etc., but we write like this. So first term is 1, next term is n into x, then n into n minus 1 by 2 factorial x square. So it goes up to infinity, because it will never stop. So when n is equal to minus 1, it is 1 minus, it is minus, so n is minus 1, then in place of x we write minus x, so minus minus plus, so it is 1 plus x, then it is plus x square plus etc, etc. Then 1 plus x to the power minus 1, it goes like this. And here general term is tr plus 1. Here it is tr plus 1 is ncr a to the power n minus r b to the power r, and in this case tr plus 1 is this one. So this is general. So we are having for n positive integer, it is the formula, and for negative integer or fraction, our formula is this. In this case we can write a, this must be 1, and modulus x is less than 1. So like this we are expanding this. So it is x plus 2 whole to the power 7. So n is 7. So 7 is 0. X to the power 7. 2 to the power 7 minus 0. So it is 0. 7c1. X to the power 6. 2 to the power 1. Then 7c2. X to the power 7 minus 2. It is 5. 2 square 7c3 x to the power 7 minus 4, so like this. So in case of n equal to 7, we get it starts from 0 and ends at 7, and it is there are 8 number of terms. If it is 5, then there are 6 number of terms. If it is 7, there are 8 number of terms. So like this. So we are expanding this one, say. So in this case n is 5, so it is 5c0. Then this 3 to the 3 is the first term, a 3 to the power 5. Then this is minus 2 by x square p whole to the power 0, so it is 1. Then plus 5c1, then 3 to the power 5 minus 1 is 4. Then this is minus 2 by x square. Actually this one is what, so it is plus, so second term is 5c1, then 3 to the power 5 minus 1 is 4, and this will be minus 2 by x square p whole to the power 1. So this becomes, because it is odd, so it is minus. So actually what we can write here also, we can write in the general term it is a plus x. So if we write here, so we can write this here, so a minus x, so a minus x whole to the power n is nc0, then a to the power n minus 0 is n, then x to the power 0 plus nc1 a to the power n minus 1, then because it is minus x whole to the power 1 plus nc2 a to the power n minus 2 and minus x whole to the power 2. So it goes like this, and that is why you can write this formula as a minus x whole to the power n. You can write it as nc0 a to the power n b to the power 0 x to the power 0 x to the power 0. So this is actually this should be b, this is b, sorry. So a plus b whole to the power n is this. So a minus x, here I am writing minus x here, so a to the power n, then minus nc1 a to the power n minus 1 and x to the power 1 plus nc2 x to the power, so sign alternates. So if it is minus, then this sign alternates because powers are odd powers. Alternatively we have odd powers for the second term, and this is minus, this is, so sign alternates. So for this minus, so 5c0, so sign is alternating, minus plus minus plus minus. So in this way we can expand this binomial. So when you have to write t5, so r plus 1 term, tr plus 1, tr plus 1 is, what is tr plus 1? So tr plus 1 is nc r a to the power n minus r b to the power r. So here we are having t5, so it is n is 7, so it is t7 is n7c, so r plus 1 is 5 means r is 4, so 7c4, then x to the power 7 minus 4, and in place of so because it is minus, so we can write minus 1 by twice x whole to the power 4. So this minus we can break it. So it is minus 1 to the power 4. It is 1 by twice x to the power 4. So here it is minus 1 to the power 4, then x cube, it is 1 by twice x whole to the power 4. After simplification, this is x cube x to the power 4, so it is 35 by 16x. Then t8, so 1 it is 1 to the power 17, so r is 7 here, so 17 is 7, 1 to the power 17 minus 17, it is again 1, and 1 by x whole to the power 7. t12, because it is minus, so minus 1, here r is 11, so minus 1 to the power 11 is here, so t12, so it is 21 c 11, then 3x square, first term is 3x square whole to the power 10, 21 minus 11, and it is 1 by 2 to the power 11 x to the power 11. Then middle term, we have to find the middle term here. So middle term, it is 36 minus x cube by 6. So middle term is this, so this is n is 9, so there are 10 number of terms. So 10 number of terms, so we will have middle term, two middle terms here, t5 and t6. So t5 is again like this we are finding. So t5 is minus 1 to the power 4, then it is n 9c 4, then 3x whole to the power 5, 9 minus 4 is 5, then x cube by 6 whole to the power 4. So x cube to the power 4 is 12, and 6 to the power 4 is 6 to the power 4. And after simplification we can write like this. And t6 is minus 1 to the power 5, r is 5 here, then 9c5, 3x whole to the power 4. So first, so one term is positive, other term is negative here. In this case there are 19 number of terms, so midterm of 19 is 10th one, so 10th, so t10, so t10 will be the middle term, and t10 means 18c 9, because it is r plus 1 means 9 plus 1, so 80, we write 18c 9, then 2x square whole to the power 9, 1 by x to the power 9. Next this one, so 12, so 13 number of terms are here, and so middle term is 7 term, so it is t7. So t7 is 12c6 r, because r is 6 here, so it is this one. And here you see there is no x, this is because they are this is same power of x, and in the middle term, so the r is 12 by 2. Then it is for this is x to, here you see x to the power 4. So for this type of problems we write the general term. General term is 15cr, tr plus 1, tr plus in one formula is ncr, so it is 15, n is 15, so 15cr, then x to the power 4 whole to the power 15 minus r, and 1 by x cube whole to the power r. Now 15cr, after simplification we are getting this, and we need x to the power 4, so this x to the power, this should be 4, x to the power 16 minus, we don't know what is r, but in the first term we will have r equal to 0, so it is x to the power 60. In the second term we will have r equal to 1, so 60 minus 7, it is 53. In the third term r is equal to 2, it is 16 minus 14, like this. So if we can have x to the power 4, then this must be equal to 4. 60 minus 7 r must be equal to 4, so 60 minus 7 are equal to 4, then r equal to 8. So what we have, we need to write x, r is 8 here, so r is 8 means it is 9 term, t9. d9 is, it is 15c8 x to the power 4, so coefficient is 15c8. Then next one, it is x to the power 10, So x to the power we need to find that, we need to write the general term. So it is t r plus 1. So t r plus 1 is formula is minus 1 to the power r, then 11 here, because minus 1 means because it is minus, so it is minus 1 to the power r. So you can note it down also. So in case of a minus b whole to the power n, t r plus 1 is, we can write it as summation r from 0 to n. This is minus 1 to the power r n c r a to the power n minus r b to the power r. So this is our general term, minus 1 to the power r n c r a to the power n minus r b to the power r, and because it is minus, so this is a minus 1 to the power r 11 cr 5x to the power 6 is the first term, 11 minus r, and second term is 3 by xy whole to the power r. So after simplification we write this as this numerical as 5 to the power 11 minus r, and then x power of x is 66 minus 6 r, then this is numerical again, and it is variable 1 by xy whole to the power r. Now so x to the power 6, so x to the power 10 we want, we need not find power of y, but we need to find x to the power of x. So this is, so we consider only this one, x to the power 66 minus 7 r. In the general term, power of x is 66 minus 6 r. So this 66 minus 6 r should be equal to 10. So this is 10. So r is 8. So r is 8 means we write t9, and here we write r to the r is 8. So this is minus 1 to the power 8, 11 c 8, 5 to the power 11 minus 8, x to the power 10, 3 to the power 8, and 1 by y to the power 8. So coefficient means this we omitted in the other part. This is 1 is 11 minus 11 c 8, then 5 to the power 3, then 3 to the power 8, and 1 by y to the power 8. So this is the coefficient of x to the power 10. Similarly this one, x to the power minus 1. So here we should write this 32 minus r 3r, this should be equal to minus 1, and after simplification we can find r equal to 11. This is of same type, this is of same type. So find the independent of x means we need to find that, as we found power of x is like this, minus 1. So here we should make power of x 0. So independent of x means x to the power 0. So it is x to the power 0. So so this is it. So in the general term we are getting x to the power 8 minus 4r, and so it is 8 minus 4r is equal to 0. So r is equal to 2, this one. So r, we are making this power as 0 and solving it, r is equal to 8. And this find the value means root 2 plus 1 whole to the power 5 minus root 2 minus 1 whole to the power 5. So a plus b, so as in the general case, what we got a minus b whole to the power n, sign alternates. So a minus b whole to the power n, a plus b whole to the power n. So some terms here sign alternates. First term is positive, next term is negative, then positive, then negative. So when we add a plus b whole to the power n, a minus b whole to the power n, then something gets cancelled. So this is the sum. So minus 1 to the power r. So when r is positive, when say 5c0, 5c2, 5c 4, then this get cancelled, only remains odd terms. So 5c1, so here it is, this term this becomes minus, so minus minus plus, so it is 2 to the 2 into 5cr. So when r is odd, so how many odd we will have? So r 0, after 0 it is 1, then 3, and then and 5. So 1 3, r is equal to 1 3 5. So we find this term and we multiply by 2. And if it is positive, so if it is positive, then what we have, this even number, even r's we need to keep. So it is 0 to 3, 0 to 3, and only terms are, so 0. So when r is equal to 0, this is positive, this is positive. When r is equal to 1, it is positive, it is negative, so this will get cancelled, same value, but it is sign will alternate. So for when it is plus, we need to keep the even r, and when it is minus, we need to keep the odd r's. So like this we calculate this one and expand up to fourth term. So this is for general binomial theorem. So general binomial theorem, this is our formula. General binomial theorem, our formula is this formula, a 1 plus x whole to the power n. So this formula we are applying here. General, this one up to fourth term. So this is 1, so it is 1, then n is minus 1, so it is 1 plus nx, x is twice x, then minus 1, n into n minus 1, so n is minus 1, so minus 1 minus 1 by 2 factorial, then x is twice x whole square, then minus 1, minus 1 minus 1, minus 1 minus 2, then 3 factorial, it is twice x whole cube. So up to fourth term, so only first, second, third, fourth. After that we need not find this. So we calculate this 1 minus twice x plus 4x square. This 2 factorial, this is 1 into 2, this will go. This is 3 factorial, this is 1 into 2 into 3. So it is sign will be minus, so 3 factorial will go and my sign will be minus, so minus 8x cube. Then number b we see 4 plus 3x, we write it as 4 plus 3x whole to the power half. Now we need, because we need 1, so we take 4 common, then this is 1 plus thrice x by 4 whole to the power half. So square root of 4 is 2, then 2 we take outside, and it is 1 plus thrice x whole to the power half. Now n is half and x is thrice x by 4, so this 2, then 1 plus n is half, this is x, then 1 by 2 factorial, then n into n minus 1 into x, this whole square, then it is n into n minus 1 and minus 2 divided by 3 factorial, this is thrice x whole to the power 3. Now we simplify this, so 2 is here, there is 1, then thrice x by 8 minus, so this is minus half, so minus 1 by 4. So after simplification we get this one. Then this one, this is cube root, means power is 1 by 3 in the denominator. So when we take here we write 2 minus x cube whole to the power minus 1 by 3. So 2 we need to make 1, so we take common, then it is 1 minus x cube by 2. So 2 to the power 1 by minus 1 by 3, it is coming outside, and it is 1 minus x cube. So so we need to expand this one, 1 minus x, this is 1 minus, this is x, and n is minus 1 by 3. So it is it is kept common, then this 1 plus n into x, n is minus 1 by 3 and x is minus x cube by 2, and plus 1 by 2 factorial is n into n minus 1, then this is minus x cube by 2 whole square up to 3, we need. So it is 1 by 3 factorial n minus 1, n minus 2. This is x cube. So after simplification we get this one. This, how will you do it? This x cube. So two expansions are here. One is 1 plus x square whole to the power half, and the other is 1 minus x whole to the power minus 1. So we are expanding this both. Now we see x cube. So these are the expansion. Two expansions are here, and we are multiplying this. So first is 1 into 1, then it is the power x square. If we multiply x square by 1, we get x squared. We get a term containing x square. Then it is x to the power 4. This is x square. We need this power coefficient of x cube. So x cube is with this x cube into 1, and this term with this. So second term of this expansion, second term of this expansion you multiply, and fourth term of this expansion and first term of this expansion. So this will give us x cube. So it is, these are the value. We are adding it. It is 3 by 2 x cube. So in this, when we multiply, we get this term containing x cube. So coefficient is 3 by 2. Then, so this you can see, and you will have this. I think you can understand this after looking at it. Next, it is for binomial coefficients corresponding to the power n. So C naught. So because our expansion is summation of NCR a to the power n minus r b to the power r. So this NCR we say CR. So CR is the, so when we write C naught, C1, C2 up to Cn, if n is 4, then we will have C naught, C1, C2, C3, C4. If n is say 6, then we will have C naught, C1, C2, C3 up to C6, like that. So we have to prove this. Now we see C naught plus C1 plus C2. When we have to prove it, in place of C naught we write NC0, then NC1, NC2, NCn, and with this we are multiplying by 1. So we can write n 1 to the power n minus 0, 1 to the power 0. This is 1 by n minus, because all are 1. And comparing with this expansion, the formula, we can write it as 1 plus 1 whole to the power n. So it is to the power n. So this is the proof. Second one, C1 minus 2C2 plus 3C3. So C1 we write NC1. NC1 is n factorial by 1 factorial n minus 1 factorial, minus 2 into NC2. NC2 is n factorial by 2 factorial n minus 2 factorial. Now we take common n. N is taken common. Then what we have? This is 1. N this is n into n minus 1 factorial. So n minus 1 factorial will go. So it is 1. Then n after taking common n minus 1 factorial is here. So this is n minus 1 factorial, then 1 factorial, 2 goes, it is 1 factorial, then n minus 1. See this n minus 2, we can write n minus 1 minus 1. Again 3 goes, 2 factorial remains, n is taken outside. So it is n minus 1 factorial, and this is n minus 1 minus 2 factorial. So what are having this C naught minus C1 plus C2 up to C n minus 1, because it is n minus 1 C1, n minus 1 C2, n minus 1 C n minus 1. This is n minus 1 C n minus 1. So it is n C naught. This is C naught, C1, C2. Sign is alternating, and this one is, last term is Cn minus 1. And like this, we here signs are alternating. So plus minus this. So it is 1 minus 1 whole to the power n. so it is 1 minus 1 whole to the power n minus 1. Last is n minus 1, so it is 1 minus 1 whole to the power n minus 1, so this is equal to 0. Then this number C, for C, to prove this one, what we will do, 1 plus x whole to the power twice n, so this is 1 plus x whole to the power n into, so this is base is same, so power is n plus 1, so it is twice n. Now we expand separately, so coefficient of x to the power n, so here it is twice ncn. So this left hand side, it is our general term is summation, this is twice n c r x to the power twice n minus r, 1 is 1 to the power twice n minus r x to the power r. So when r is equal to n, it is coefficient of x to the power n, so we write twice n minus n, this is twice n minus n, so twice n minus n is the coefficient of x to the power n, so it is equal to twice n factorial by twice n minus n is n factorial and n factorial. So this is the coefficient of x to the power n in the left hand side, and on the right hand side, this is our product is this, because our expansion is this ncr 1 to the power n minus 1 x to the power r, ncn minus r 1 to the power r x to the power n minus r. And so when we multiply this, so what we'll have, x to the power r into x to the power n minus r, and it is, so we can expand this like this, so 1 plus x to the power n is nc0 plus nc1x plus nc2x plus this into this into 1 plus x whole to the power n. So first we can write it as this, into, we can write it as from this term, if we write the last term as the first term, what we can write, nc is n, then x to the power n plus nc n minus 1 x to the power n minus 1 plus this, we are writing the last term in the first term. So this term into this term, we will get x to the power n, this term into this term, we will get x to the power 1 plus x to the power n minus 1, so it is x to the power n. So every term, this respective terms, product of this respective terms gives us x to the power n. So its coefficients are nc0 into nc1, nc1 into ncn minus 1, nc2 into ncn minus 2, etc., etc. So this is c0, cn. So what you see in this expansion, our coefficient of x to the power n is nc0 into ncn plus nc1 into ncn minus 1, etc., etc. So it is c0, cn, c1, cn minus 1 up to cn, c0, and this becomes equal to twice n factorial by n factorial n factorial. So it is proved. So we need to prove this one. So this is the coefficient in the right hand side, and this is the coefficient in the left hand side. So these are the assignments you can try. Procedure is same, you can try it. Then logarithm, we see logarithm is, so logarithm, laws of logarithms are there. This log of mn to the base a is log of m to the power n plus log of n to the power n. So what is log? Log is, if we have a to the power x is equal to n, then we write log of n to the base a as x. So because suppose it is 2 to the power 4 is equal to 8, what we write, log of 8 to the base 2 is equal to 4. So this is the logarithm. Here base is 2. So this is the base. So if base is 10, we say it is common logarithm. If base is e, then we say Napierian logarithm or natural logarithm. So and these are the laws. So log of m n to the base a, base must be same. This is log m to the base a plus log of n to the base a. So this is log of m to the base a. So if we have to calculate this, say we have to write log of 6 to the base 2 plus say log of 8 to the base 2. What you can do, this is equal to log of base is 2, it is 6 into 8, 48. We can write it. But if this base is not same, suppose we are having log of 6 to the base 3 plus log of 8 to the base 5. So this we cannot do. We cannot write log of 68. So base must be same. So this cannot be simplified. This cannot be simplified. So this is important that base is same. Then this is one law, m to the power n. So this law, in most cases we apply this. So log of say base is 2, it is say 8. So this we can write it as log of 8 is 2 cube, base is 2, and this we are writing as 3 is the power, so 3 is here, log of, then this is 2, this is 2. So log of here again we apply this one, log of a to the base a. So if base is same with this, then this value is 1. So this we can write it as 3 into 1, this is equal to 3. So this is, so in many cases we simplify it like this, logarithms. So for this we apply this formula. Then log of 1 is always 0 irrespective of a. Log of a to the power a is 1. So this one. So these are the proofs. So to prove these things, log of a to the power m is equal to x. We what do we do? Log of, so we assume, so this is we are applying. If it happens, if log of n to the base a is equal to x, then we can write a to the power x is equal to n. So this thing we are writing this. So this is equal to x means a to the power x is equal to m, and this a to the power y is equal to n. And we know these laws, this indices, and this is a to the power x plus y, because these are the same, so power is x plus y. Then after in place of x we are writing log of m to the base m, x is this one, y is this one, and we get this one. And these are the laws of logarithm. We are proving like this, very simple. Then this is because 1 a to the power 0 is always 1, whatever be the value of a. So this will give us log of 1 to the base a is this. This is power 1, value is same. Now we are simplifying this. So this 216, so 216 we write it as power of, in power of 6, so that we can apply the formula 6 to the base 6. So what we'll do here, it is log of, this is base is 6, then it is 216 is 6 cube. So we are taking 3 will be taken here, then it is log of a to the base a. So 6 to the base 6, so this is equal to 3 into 1, so this is equal to 3. Similarly, this one is log, so base is 11, 121 is 11 square, so 2 will come here. It is log of a to the base a, it is 1, so it is 2. This one is log of, this is equal to log of, we write the base is 25, so 5 we can write 25 to the power half, so half will come here. It is log of a to the base a, and it is half into 1. This is it is log m by n, it is log m minus log n, or this so what we do here, 7, base is not written, means base is common. So number 1 we can do it like this, log of 16 by 15 whole to the power 7 we write, because this coefficient will become the power of this. Base we are not writing because base is common. Then plus it is log of 25 by 24 whole to the power 5, and plus log of 81 by 80 whole to the power 3. So what we are getting, log of a plus log of b plus log of c, this becomes log of, I am erasing this thing, so this becomes, so this is equal to log of, we multiply all, we multiply 16 by 15 whole to the power 7 into 25 by 24 whole to the power 5 into 81 by 80 whole to the power 3. Then we simplify this bracketed values, so log is here, then we write in terms of fraction. So 16 means 2 to the power 4, to the power 7 it is 28. 25 means 5 square, so it is 5 to the power 10. 81 is 3 cube, so it is 3 to the power 9. Not 3 cube, 3 to the power 4, so it is 12. It is 12. It is 12. 3 to the power 12. Then 15 to the power 7. 15 is 3 into 5, so 3 to the power 7 into 5 to the power 7. 24 is 3 into 8 or 3 into 2 cube, so it is 3 to the power 5, and 2 cube is 2 cube to the power 5 is 2 to the power 15. 80 is 5 into 16, so 5 into 2 to the power 4, so 5 to the power 3, and 5 into 16, 16 is 2 to the power 4, so 2 to the power 12 into 2 to the power 2 to the power 12. Then this is equal to log of, so 3 to the power, numerator 3 to the power 12, and denominator it is 7 plus 5, so this will go, 7 plus 5 is 12. This is 12. So 3 will go. Then 2 to the power 18. Here power is 2 to the power 15, 2 to the power 12. It is 2 to the power 27. So here remains 2. It is 2. 5 to the power 10. This is 7. This is 3. It is 10. So remains only. So 5 to the power 7. 10 will go. So remains only 2. So it is log of 2. So answer of, so simplification of this is log of 2. This is same. This is log of 25 by 33 into 55 by 46 into, this is minus, so it is division. So it is 69 by 65. Next one is number 4. We will have it. So number 4, it is equal to log of, it is within bracket we write 2 into 2 to the power 12. 12 to the power half. So 12 to the power half into 2 by root 3, 2 to the power half, into 1 by 3 to the power half. Then minus means division, so it is 1 by 2 to the power half. So this 2 to the power half goes with this, bracket close. Then 3 to the power half, 3 to the power half will be here. So this is equal to log of, this is 2 into, this is 4 into 3. So 4 to the power half is 2 and it is 3 to the power half. And this 3 to the power half is here, into 1 by 3 to the power half. So this will go. So remains log of 4. So answer is log of 4. So this is the way of simplifying this. I am erasing all this. Erasing this one. Now then number 5 we see x to the power log x log y minus log x. So x to the power log y minus log x. Now if we do it, number 5, log, we are taking, say, log of within bracket we write x to the power log y minus log z into y to the power, etc., etc. So for this we are taking log. Then log of m into n we can apply, so we can write it as log of x to the power log y minus log z. Then we can write plus log y to the power log z minus log x, and again plus log z to the power log x minus log y. And what you can do now, so base we are not writing, don't be get confused, no base is here, means what, base is common. So this is the power, so log y minus log z, this will come as coefficient. So what we'll write for the first term, so it is log y minus log z into, this is the coefficient, and this log x. Similarly plus log z minus log x, log z, second term, it is log z minus log x, it is coefficient of log of y. And for the third term, log z minus log x minus log y, so log x minus log y into log of z. And after multiplication, we will have this is equal to, so log x, so what we will having, log x into log y minus log z into log x. So log x into log y, here is minus log x into log y, so this will be 0. So answer will we simplify, we will have it as 0, and this 0 we can write as log of 1, log of 1. So what we are having, log of the left hand side is equal to log of 1, means what, left hand side must be equal to 1. So taking log of this, we are having log of 1, so this implies, now we can write, implies left hand side is equal to 1. It is proved. Then this is also same, we are taking log of this, then it is log y minus log z into log of yz, and log of log y minus log z is log of y by z, and it is y by z. So ultimately we get the value as 0. 0 means log 1, so again it is this. Then number 6 we see, it is, let us erase this thing. Next, log of 3 to the power 3 to the base x, base, these are base. So because base is same, so number 6 what we can write here, number 6 1, so base is same, what we can do, it is log of base is x, we can multiply all 3 into 9 into 729, 729, this is equal to 9. So what we can have, this is equal, this implies x to the power 9 is equal to 3 into 9 into 729, it is power of 9 cube, 9 cube. So this is equal to 3 into 3 square into 3 to the power 6. So 3 to the power 6. 9 cube means 3 to the power 6. It is 3 to the power 9. So what we are having, x to the power 9 equal to 3 to the power 9. This implies x is equal to 3. So in this way we can have it. Number 2, what we will have here, number 2, it is, we can write, this is number 2. So this is log of 3x minus 1, so log of 3x minus 1, base is 10, so it is 3x minus 1, and this minus 2 we take as power, so it is log of base is 10, it is x minus 1 whole square is equal to 1. So it is log m minus log n, it is log of m by n. So what we are having, log of base is 10, then it is 3x minus 1 by x minus 1 whole square is equal to 1. And we need space, so yeah, I am erasing this. And what we are having, 3 egg. So 10 to the power 1, because right hand side is 1, so it is 10 to the power 1. This implies 10 to the power 1 is equal to try 6 minus 1 by x minus 1 whole square. Now so this is an equation, so this implies try 6 minus 1 x minus 1 whole square is x square minus twice x plus 1, so multiply by 10, so it is 10x square minus 20x plus 10, and this implies 10x square minus 23x plus 9 equal to plus 11, sorry, not 9, it is 11, equal to 0. 20x, and then solve it. So it is 10 it is 2 into 5, try 6 minus 1 x minus 1 whole square, try 6 minus 1 x minus 1 whole square, this is equal to 10. So this would be equal to 10. So simplify it. It is a quadratic equation. We will have some solution. 11, 10, 110, then 20 into 3, 13, 11, or you can write it as quadratic. So x is equal to minus b plus minus root over b square 23 square minus 4 into 11 into 10 divided by b square minus 4ac divided by twice 2 into 20, 2 into 10, and we'll have some solution of this. So this is the way of solving this one. Log of x by b minus c, we are multiplying by a log x is equal to ab minus ac, then b log y is equal to bc minus ac, then add all this, then denominator is 0, and we will have a log x plus b log y plus c log z is equal to 0. So a log x means log of x to the power a, so x to the power log of x to the power a plus log of x to the power a plus y to the power b plus z to the power c is equal to 0, means x to the power a plus y to the power b plus z to the power c is equal to 1. So this is for practice. A square plus b square is equal to 14ab. So we can write it as this: a square plus b square, a square plus b square, a plus b root over a plus twice ab. If you can write it as this, twice ab is equal to 16ab is equal to a plus b whole square. A plus b log of ab root over a plus 16ab, then log of 2 log of a plus b by 4. So this we write as ab is equal to a plus b by 4 whole square. So ab log a, now you take log, so log ab means log a plus log b is equal to log of a plus b by 4 whole to the power 2. 2 you can take here and then divide by 2, we will get the answer. So this is logarithm. These are assignments. These are, you can do it, you can try it for practice. These are some practice questions, very simple questions. You can do it.